Good afternoon, everybody. My first ever trip to Western Pennsylvania. It's very nice out here, actually. Warmer than it is in Vermont. I've already scraped my windshield twice at home.
That's okay, you're using gas.
Fire this up. So I am going to talk about a little bit what we do in the electricity world as opposed to the gas world. There are some similarities. I've learned a lot today sitting in the audience and then listening about gas and coal, the work that you folks do. I would say that managing an electric transmission corridor is probably not a lot different than managing a gas pipeline corridor. We are the state's high voltage transmission system in the state of Vermont. We were the nation's first transmission-only utility in the United States. Back in 1956, the state of Vermont decided that one distribution utility should not own all of the transmission in the state, but should be a standalone entity. We do have 1,600 miles of fiber optic line. We're essentially the state's communication backbone for smart grid, and that data is also used for communication with our 58 transmission facilities throughout the state. We do have a statewide radio network. Again, that's for utility use only. We're not allowed to use it for EMS, although they would love to have our system. We have 98% coverage of the state of Vermont. Just with the FCC guidelines and everything, we're just limited to utility use only. But as part of that data, it is more like a cell phone network, so we can get telemetry back. So that's how we do automatic vehicle location and things like that to keep track of our crews out in the field. Unplanned power outages. Obviously, that's kind of unique to electric utilities, but again, there are gas outages, so there are some similarities there. In the electric world, this is what we face pretty much every day. Mobile GIS data collection and desktop GIS obviously doesn't solve all of these problems, but it definitely helps us to mitigate a lot of these. One of the ones I wanted to point out, if I can get the mouse back, flooding. Flooding may not be something that you think about of how GIS can help to mitigate that, and I'll talk about that in a few minutes. But we had a very significant, it wasn't actually a hurricane. We got the byproduct of Irene. By the time it reached Vermont, it was a tropical storm. The weather forecasters, in their great expertise at forecasting hurricanes, didn't think Vermont was going to be impacted a whole lot. It was going to be mainly a Massachusetts and Connecticut event. Wow, were they wrong. They were very wrong. It was the most significant flooding event Vermont has seen since basically 1927. If you look, actually, let me go back one level. This is what it looked like before. We had a transmission line corridor. I don't know if you can see it, but the corridor runs. That's one of our structures. What happened was it was a very fast event. It happened over the course of less than 36 hours. It was here and gone, unlike what Boulder is experiencing, where it's lasting for days and days. It was here and gone. And wherever there was a bend in a stream, the stream just took over and made it even worse. So a lot of the utilities in Vermont, you can see 73,000 customer outages where they were out for days and in some cases weeks because you just couldn't put the lines back up. There were no place to put the lines. They had to purchase new easements, get special state permission to let them put those lines up without going through all the normal regulatory issues that we have to go through in Vermont. We only had, luckily for us, this was what we considered a major event for us. We actually lost 3 transmission structures, but relative to the rest of the utilities in Vermont, we were spared pretty significantly. That's basically where that was located, in one of the lower rainfall areas, but that was still a pretty significant event. And again, not all of this can be mitigated through mobile GIS data collection, but we've done a lot of work. We're in the process of doing some equipment failure data collection, some structure assessment work. Trees and vegetation is obviously the biggest one. The federal government really frowns heavily on transmission utilities having tree outages. And I'll talk about that in a little while, in a few minutes. Wildlife, earthwork, vandalism, those are things that are really obviously difficult. Vehicle accidents, those are what we live with. But we do what we can to decrease as many as we can and keep the lights on. Our right-of-way manager in 2007 said, this may be a technology that we could use to help meet some of the new NERC standards. NERC being the National Electric Regulatory Council. It was part of FERC, the Federal Energy Regulatory Group. This was as a result of the 2003 blackout. Last month was actually the 10th anniversary. They started putting a lot of significant regulations on transmission utilities, transmissions that have transmission lines above 230 kV. We evaluated lots of off-the-shelf products. I say lots of 3. It was pretty much in 2007 all there was out there. Most of them were geared towards urban tree inventories. It wasn't really going to suit our needs. So finally a vendor, out of frustration, said, well, you should just create your own. So that's what we tried to do. We looked at Esri's ArcPad platform as probably the solution for us. It was met with some resistance by the Vegetation Management group, basically said, don't do it. One of our foresters had used it when he worked for Florida Power and Light and had very poor experience with it. But he was open to trying it because we were going to do it anyways. We spent 2 months developing this tool. We spent $30,000 to create it, and again, 84% of that was primarily hardware and software. I developed the initial tool. I wrote all of the code. I worked with the vegetation manager to determine what he was going to specifically need, and we rolled it out on August 28th. Ironically, 4 years to the day that Hurricane Irene came through, 4 years later. Day number 1 was pretty good. The tablet computers that we decided to go with worked very well. They were big, they were heavy, but we managed that. They needed to have screen visibility and storage capacity. They wanted to have imagery that we have for the state of Vermont. No major flaws. They adapted well to it. And luckily, they just wanted more tools. It was, again, a very thin tool when we first rolled it out, and it's grown significantly. Me being a GIS guy, thought we should have sub-meter accurate GPS receivers out there, and that was an abysmal failure. We had lots of connectivity issues, whether it was with a cable or Bluetooth. Carrying the extra devices was difficult for the foresters. So we ended up going with just the internal GPS receivers, the typical 3 to 5 meter receivers that you have in a typical navigation system or your smartphones today. We did test out Windows mobile devices. They really didn't work because they didn't have the storage capacity, they didn't have the screen size. That was a big requirement. We needed to have a lot of data. Our foresters at any moment can be called to any other area in the state of Vermont, so they have to have all their data available for the entire state. It's a big requirement, and it does require a lot of storage. I've got a big list of keys to success, but in my mind, these were the 4 biggest ones. The custom tools. We found out pretty quickly that the nice tools that Esri gives you out of the box for collecting points and lines and polygons, no forester is ever going to use that. It needed to be a completely custom tool that walked them through the complete data collection process. We needed to have tech support anytime, anywhere. Another benefit of doing it in-house. Several times when we first rolled this out, I was diverted from my normal commute to a right-of-way corridor someplace in the state to help with some sort of tablet computer issue. But that was short-lived. They rapidly adapted to the technology, and it wasn't much of an issue going forward. Bug fixes and enhancements have become really important. If we had bought an off-the-shelf product, when there are bug fixes, you don't get those bug fixes turned around. You have to live with them for a certain period of time. Now they live with them for only a day or 2 or less if they happen to be coming by the office. When the tool started growing and expanding and I couldn't keep up with it anymore, I hired a dedicated GIS technician. So he is solely focused on managing that software development and managing the data associated with it. I know that's probably not a luxury that a lot of companies will have, having a dedicated resource to support the field personnel, but it has made it extremely successful for us. And without that, I don't think we would have had the adoption of the application that we have now. This is currently what we're using in the field. Depending on the type of data that's being collected and how rugged of a terrain they're working in, we will either use the Panasonic Toughbook with cell phone and GPS kind of cards in them. No onboard cameras for the Panasonic Toughbooks. You can get them, but they're really, really poor in their location. They're on the actual bottom side of the computer, so it's just a really poor design. So we do use some of these Ricoh ruggedized computer or cameras. They're Bluetooth enabled, so when you snap the picture, it just Bluetooths right to the computer. It's a pretty decent usage of it. We do work with some of the Trimble Yumas. They're much more rugged. The batteries last a significantly longer time, and they have better onboard cameras. And then we also do use the True Pulse laser rangefinders. Our foresters use those so that when they meet with a landowner and say, this tree needs to come down, it's X number of feet tall, the landowners typically will never agree with you how tall their tree is because, that's Aunt Betty's favorite tree and she doesn't want it cut. If we show them through the rangefinder the height of that tree, it's usually understood that we're telling them the truth, that if there is an issue, we will point out the deficiencies in the tree, if it's insect or rot, or the trunk is beginning to split, why those trees need to come down. And this technology has helped us a lot. So Vegetation Management, that was the first department that adopted this technology, and it wasn't very long before other departments were knocking down our door to get some of those cool tools that they were using in the field. Data sharing opportunities started to evolve. The environmental team had some nice wetland data, other environmentally sensitive features, rare, threatened, and endangered plant species, archaeological sites, Rhina rare and implaceable natural, I can't remember what the A is, but Rhina sites. And so when our foresters are out in the field, they have to be careful where they use herbicide. They're not allowed to use herbicide in certain types of wetlands. They have to be cognizant of the fact that we're not trampling on rare plants. We have to be careful of the ARC sites, not disturbing those. We don't do our own vegetation management. We hire that out to be done by third-party contractors. So having high-quality data and either paper map books that we generate for them, or if we give them a tablet computer to use in the field, we've seen a significant amount of decrease in issues where herbicide was sprayed where it shouldn't have been sprayed, and other issues like that. It's really helped a lot. The contractors have been very happy to use it. Our telecommunications department, when we started doing that 1,000 miles of fiber optic cable build out that Aaron had mentioned in the beginning, we didn't have a vast database of the distribution network. A lot of the fiber optic cable that we put on was on distribution and subtransmission equipment. We needed, because we're doing the communication backbone for smart grid, we need to get this fiber optic cable to where these subtransmission facilities are. The distribution utilities, some of them didn't even have good, accurate, or any data to speak of. So we were collecting a lot of the information, photographs of their poles for them, and so we turned it over to them when we were done, so that our engineering firm that we worked with could start to design these fiber optic attachments. Is it too much for the pole? Is it okay? Additional work that needs to be done. The environmental team, they adopt it, like I said, they're using it to map wetlands. They will hook up a higher accuracy GPS receiver to the tablet computers so that they can more accurately map their flags for their wetlands. We're also now able to have a database of all of our access roads to our transmission lines. Before 2007, that was just tribal knowledge. Only the line crew knew where every access road, and you know what, you better take that guy a bag of M&Ms because he's awful mean, and he might shoot at you if you don't get a bag of M&Ms from you. So the tribal knowledge is always something that all utilities are faced with. You know, as we have an aging workforce and people are retiring, a lot of that knowledge goes. So this has been a big help of getting that information out. Our line crew, we roll out equipment for them. We have a photograph of every structure on that tablet computer, so before they head out into the field, they can take a look at what that structure looks like if they're called out for an outage and determine what equipment they need to take with them. There's a full database behind it so they know more specifically what the structure types are. And then they can take new photographs when those structures are replaced. Our real estate department, they primarily use it for encroachments, going out and mapping encroachments and working with landowners when there is an encroachment, if they've built a shed, or the worst case scenario is if they've built their house inside of the right-of-way. If, unfortunately, you know, again, this is not uncommon for just electric utilities, if we don't clear our entire right-of-way, a lot of times people assume that, well, that's the right-of-way, that's what's cleared. And so they'll build outside the corridor, but we may have another 50 or 100 feet of corridor that we have access to, and now we have a problem. Hopefully the landowner gets lucky enough that that's not a corridor that we ever plan to expand. I should have brought a couple pictures. We have some pictures where the corner of buildings get lopped off during construction, and they have odd shapes, or whole foundations have had to be removed. So, you know, companies that go out and do deed research and legal firms, you know, oftentimes their insurance is required to cover that because, you know, that was part of when the landowners bought a piece of property and wanted to expand it. They should have known that. So as part of some of the aerial imagery that we do through LiDAR, we're doing a lot of look ahead for the encroachment stuff that we run into. We also worked with one of our distribution utilities in the state of Vermont. They reached out to us. They knew we had this technology. So Andrew Flynn, who you'll hear from tomorrow in another presentation, he worked with them to write an application so that they could collect their entire distribution network. Small utility, just a small municipality, but they rolled out all of their smart meters. All their smart meters were mapped with this technology. All of their pole-mounted transformers, fuses, you name it. It was, their entire system was mapped using the technology that we created. Again, I've already talked about a lot of this stuff that we're inventorying. Just to highlight a couple of these, you know, the floor treatments, the danger trees, the widening, and special trees. If we build new projects now, the state of Vermont requires us to put up vegetative screening, and we have to manage that vegetation for a significant number of years after the construction is complete. So we affectionately call those special trees. And a lot of times those special trees aren't species that may not even be native to Vermont or may not be conducive to a right-of-way environment because they grow too tall. 12 feet is the maximum height of any vegetation we allow in our right-of-ways. So those trees are monitored more frequently than any of the other vegetation that we have in our rights-of-ways. Again, with the telecommunication infrastructure, you know, now we have our statewide radio network, so we're in the process of having them map all of the access roads and record information about those radio sites. So in the event of some radio outage during a storm, we can get people there as quickly as possible. Trying to be cognizant of the time. I have some slides that I probably won't show.
10 minutes.
I have 10 minutes? Okay. We did do a LiDAR project. I'll flip into that one then if I get 10 minutes. In October 7th of 2010, the federal government required every transmission operator in the United States to confirm that your transmission system can be operated safely and meet all of the National Electric Safety Code clearances. It was a huge undertaking. Luckily, we were already in the queue to do some limited LiDAR work, so we evolved that scope to include our entire system. LiDAR was not a requirement by NERC, but they certainly highlighted it in their printed NERC alert that they sent out to every utility as a way to be able to rapidly map your entire system and create a transmission model and determine where you had what we call point clearance violations, where if the transmission line is operated at max condition so that that line sags to its maximum, close, or how close it gets to the ground, that it won't be violating any clearance issues. So once we got all the LiDAR data, those were only classified as points of interest. Just because a piece of software told us that we had a clearance violation, we did not just immediately assume that that was true. This is data being collected from the air. There's a lot of human error that's potential there. So we took all of those points of interest and we sent field personnel out to go to every single point of interest to determine what was the clearance violation, if there was any. This is an area. The point of interest was here, and you can see, I don't know if you can read that, but it was simply a ledge outcrop. And even though transmission line corridors are classified as vehicular traffic, you would not be able to drive a vehicle on that ledge outcropping. So we classified that as pedestrian traffic at that point. Nobody's going to be driving on that point. So we were able to reduce a lot of our points of interest by going out there and looking at them. Either they were misclassified. We had one instance where we had an issue that we just couldn't believe was an issue. It was a clearance point in a navigable waterway. It was a swamp. There's no 25-foot sailboat mast that's ever going to be in this swamp. It was just it was just completely misclassified. The points of interest, we also did vegetation. Vegetation wasn't a requirement. It was a byproduct. Our vegetation manager said, well, let's do the vegetation work so we can look a little farther into the woods and see some of the trees that we normally wouldn't be looking at on our regular patrols. And we did find a significant number of points of interest of vegetation as well. The distance to conductor, a positive value is the tip of the tree. If it fell, will be that far from the conductor. If it was a negative number, that's how far over the conductor it would be. So if that had been a negative 9 feet of that tree would have fell across the conductor. We do 4 aerial patrols a year. It's a requirement that we have. It's not a requirement by the federal government. You just have to do an aerial patrol. We do 4 a year, and the one that everybody likes to go on as a trip is the one immediately after hunting season. Bored hunters like to shoot insulators when they get no deer. So that is a absolute must. We do a helicopter aerial patrol 4 times a year and always after hunting season. Andrew's going to talk tomorrow about the hazards of flying in what's classically termed in the flying in a wire zone, and the way we're using mobile GIS to diminish some of that hazard. And then as part of Hurricane Irene, we also developed another tool to put on that field computer for doing stream bank assessment, where we actually take some of the nationally recognized methodology for assessing a stream bank for erosion and flooding, and automated that so the environmental people in the field can put in all the different data points, and it spits out the potential for that stream bank to flood. And if it's a severe enough one, we will actually move the structure going forward to prevent any future Irene incidents. When we had Hurricane Irene, some of the flood inundation that we have exceeded 100-year FEMA flood maps. So FEMA is completely redoing their flood maps now because in some areas of Vermont, they were no good. They were completely inaccurate. We talk about mobile GIS as being a toolbox. That tablet computer, the guys think of it as a virtual toolbox. And really, it's there to help them improve safety. You know, they have a better visibility of what's going on out in the right of way. Decrease landowner issues. We've mapped all of the private and public wells within our right of way. We're not allowed to use any herbicide within 100 feet of a private well or 200 feet of a public well. So as soon as they map a well and say whether it's public or private, it automatically buffers that well. And again, we're increasing productivity. It's helping us to comply with those federal regulations and manage our transmission assets. These are just some of our results that we've, like some of the highlights. Our last sustained vegetation tree outage was in 2007. But unfortunately, this July, we had a momentary contact from an off-corridor tree. But since 2007, we've had a remarkably good stretch of luck managing the vegetation in our corridor. 27,000 trees have had to have been sacrificed to maintain that high level of reliability. But again, as a transmission utility, the federal government really frowns on tree outages. During our structure assessment program we're doing now, we're looking at every single structure in our system to determine its health. 3,500 have been completed, and 1.5% of those have been determined to be needing replaced. We have an older, aging system, and the life expectancy of the transmission poles, we are at or exceeding them. Doesn't mean they're going to eminently fail. It depends a lot on environmental conditions, the health of those poles. And we have done 84 stream banks. And this is some of the terrain that our field personnel work in. So with that, I have a couple of minutes for questions if anybody has any.